they're pretty easy. Um, and they're pretty easy to remember as well. So this should be the least of your worries. It should be the most of your worries if instead of this syntax question, it gives like what's it called? The one that's like precedence classes and you turn it into BNF. That's when it gets a bit weird. So we'll go over that in a bit as well. Which I don't know if he's going to give that on the exam, but we'll see. So this is an example of a syntax question you might get where you're given infix expressions in a certain language and they use three precedence classes, right? So we have class 1 to class 3, where class 3 is the lowest precedence and class 1 is the highest precedence. Okay. And in class 3, we have an ampersand sign and an at sign, and they're both right associative. Class 2, we have a dollar sign and a hashtag, which are both left associative. And class 1, we have a divide and a tilde sign that are both right associative. Okay. And the first question asks, here's an infix expression in the above mentioned language. Circle the operator that should be applied last when the expression is evaluated. So by last, what it means is on the top level, which operator is going to have like the rest of the symbols as their parameters, right? So we would check at the top here and we would see, okay, are there any class 3 operators? Well, let's see. We have an at here, we have an and here, and it would just be those two, and an at. Since we have two operators, we need to figure out, okay, which one is going to be applied last. And for that, we would use the associativity. For the right associative, for right associative, the one that's all the way on, that's leftmost is going to be applied last. And for left associative, the one that's rightmost is going to be applied last. So this in this example, we have and at. The and is leftmost, so this one is going to be applied last. So I'm going to circle it. Oh shit. And that one would be applied last. And then like the operands for this operator would be like what's to the left of it and what's to the right of it. So that's what it means by applied last because it's going to first evaluate what's to its left and then to its right and then it'll do this. Right? So that's why it means applied last because it needs to do all of this, and then finally that. Okay. Then here it says circle the operator that should be applied last when the following sub-expression of the expression of I is evaluated. So here, right? Well, let's check. Do we have class 3 operators in here? We do. We have this and right here, this ampersand. And we don't have an at symbol, so there's no ties. So we're going to circle this one because this is the last one. Where this will be the operands and this will be the operands for the ampersand. Then it says draw an abstract syntax tree of the expression of I. So we want to draw an abstract syntax tree of this one. Okay. So the best thing to do is I would rewrite it. So hashtag 5 ampersand u at c dollar sign parentheses 6 dollar sign d ampersand tilde y. So remember, we said that the ampersand is going to be applied last. So that's going to look like this and this. Okay. And then in the left side, we say, okay, which is going to be applied last here, the hashtag or the division symbol? Well, let's check. Do we have any class 3s? We don't. Okay, so we're going to go to class 2. Do we have any class 2s? We do. We have a hashtag. And there's nothing else here in class 2, so this hashtag is going to be applied last. So we're going to have something like this. Okay, now let's move to the right side. We say, okay, do we have any class 3 operators? We do. There's one right here, right? So we're going to case it like this. Kind of fucked it up here. I would like move this down. Okay. And then now we're going to go back to the side. Obviously, there's only one operator in here, so this is just going to look like this. Okay. And then here, there's no operator, so we're good with that side, and now we have to do this side. Now, there's only one operator on the top level here, and it's this dollar sign, which I actually fucked it up. Let me rewrite it. Dollar sign. Only one operator on the top level, so it's going to look like this. Okay. Now, finally, we have to figure out this one here. Now, this one was already part of this question. It said, which is going to be applied last? It's going to be the ampersand. So, so for this ampersand, we're going to like this, like this. Okay. Then on the left side, we see, okay, we have $6 $D. There's only one operator here, so it's going to be dollar sign. And on the right side, there's only one operator here, is a tilde, so that's just going to be the tilde. So that. Okay. And now given this, we have to construct an abstract syntax tree. Okay. And so remember, the root is always going to be the last operator to be applied in each of the subtrees. So first, the last operator to be applied here is the ampersand. So we're going to write ampersand. Then on the left side, the last operator to be applied is the hashtag, which the hashtag just has one um, input, which is the division symbol. And the division symbol just has one input, which is the 5. Okay. Then on the right side, the last thing to be done is the ampersand, sorry, the at symbol. The left of the dollar sign is going to be the C. Wait, let me, oh, this is like not leveled. Let me move this down. What did I just do? Okay, let me just rewrite it. Okay. Boom, boom. We're going to have the U, and we're going to have the dollar sign. Dollar sign is going to have C, and the last operator to be done to the right of the C is the ampersand. So actually, wait, no, hold on. Give me 1 second. Yeah, that looks good. Okay, ampersand. Okay. Then to the left of the ampersand, it's the dollar sign. So dollar sign, and to the right of the ampersand is the tilde. So we have tilde. To the dollar sign, we just have 6 and D. So 6 and D. And then for the tilde, we just have Y. So Y. Okay. and this would be the abstract syntax tree. Any questions about this? The abstract syntax tree is pretty simple. Okay. Questions? So then, the next part of it says rewrite the expression in prefix syntax. To do this, all you need to do is do a pre-order traversal on this tree, which you all should know how to do, hopefully. So I'm going to write pre-order. And remember with pre-order, it's just parent, left child, then right child. So in this case, it'd be ampersand, hashtag, divide, 5, ampersand U, $C, ampersand, $6D, tilde Y. And that would be the prefix. So it's going to be ampersand, hashtag, divide, 5, at symbol, U, $C, 8, $6, D, tilde, Y. And that would be pre-order. Or sorry, I shouldn't write pre-order. I should write prefix. Okay. So prefix. But now let's say, okay, the question says, what about postfix print syntax? Which actually does it say on the next slide? No. What if it says postfix syntax now? So postfix, you just need to do post order traversal on this tree, which again, hopefully you guys should know how to do. So postfix syntax. Again, postfix syntax is just going to be a pre-order post-order traversal. So we're not going to do this one first. So boom, 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 visited, 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 not visited, 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 and that would be a post-order traversal. So again, that would be 5 divide hashtag U C 6D $Y tilde ampersand $. Wait, hold on. I messed up. Oh no, I didn't. $, ampersand, and oh sorry, at, and then ampersand. I think that should be good. Let me see. 5 divide hashtag UC60 $Y tilde $8 at ampersand. Yeah, that's good. And that would be postfix. So this is prefix, this is postfix. Okay. And that's all you really need to know for syntax. Again, he can give the what's it called? He can give questions about like eBNF and BNF, but we did that 5 days ago, so hopefully you should still remember that. I don't want to waste too much time going over that, so I'm not going to. Um, but you should still remember that for eBNF and BNF. So he can give questions like that because that's still considered syntax. He can also give one that's like, okay, given this over here, like given this, make a make a BNF grammar based on this precedence class, which is what we got in exam 1, if you remember. So for that, you just need to remember the pattern, right? Where class 1 operators would be put into a class 1 production, class 2 operators will be put into a class 2 production, class 3 operators will be put into a class 3 production, and so on. And then from there, you would just match the uh, productions. So you would make another production called expression 3 that would match with class 3. You would make a actually, let me just do it with for this one, just for some practice. So let's say we have uh, class 3, which class 3 contains the ampersand and the at sign. And then after this, we'll take a break. Uh, class 2 contains the dollar sign and the hashtag. So dollar sign and the hashtag. Okay. Oh, actually, wait, hold on. Yeah, these need to be separated because they're binary and prefix. Unary. Uh, I'm just gonna assume that they're all binary because the ones that he's given, they've all been binary. So I don't think he's gonna change that. Hopefully. Actually, no. Let's just figure it out. So class 2B, that'll represent binary. So B, and then class 2 uh U will represent unary. So that should be a hashtag, I think, right? Yeah. Then class 1 binary, that is a divide symbol. And then class 1 unary, prefix unary, is a tilde. Okay. And so what we need to do is we need to match expressions to these operators, right? Where we would have expression 3, expression 2, expression 1, expression 0. So for the number of classes, there's going to be plus 1 expressions. Oh, sorry, this should be 0. Where 0 is going to contain constant, variable, or parentheses, expression 3. Right? So that's always going to be the layout for expression 0. And then for expression 3, we know that expression 3 is right associative. So there's two things we need to do. One, we need to call upon expression 2 as an option, so expression 2. Or since it's right associative, the current expression that we're in is going to be recalled on the right. So we're going to say expression 2, class 3, and then expression 3. So we're going to recall it on the right. If it was left associative, expression 3 would be on the left, and expression 2 would be on the right. Okay. And then in expression 2, we have again two parts where we can have expression 1, or remember class 2 is left associative. So the call to that same expression is going to be on the left side. We're going to deal with binary first. So binary, that's going to be expression 2, uh, expression 2, class 2b. So class 2b, expression 1. Oh, okay. So that deals with that case. But then now we have another case where we say class 2 unary, where it takes in one thing and it's a prefix unary operator. Okay. And it's also left associative. And so what that's going to look like is we need to make another portion where here we would say, let me think, it'd just be, I think it would just be expression 2 since it's unary. You would say class U, and there wouldn't be another expression because it's unary, I think. Uh, and then from there, if you wanted it to be whatever you need it to, you can just call upon a special one. I'm not entirely sure. See, this one's weird because it has prefix unary, so like this is not something he's given before. But you're able to see the general pattern where if it's left associative, you're just going to put the current production on the left side, then the class, and then the next production on the right side, and then such that you put the next production here. If it's right associative, the next production will be here. The then the next production would be here, the current class, and then the current production would be here. So this would be right, and this would be left. And that's the general pattern for this. Um, okay. But again, I think this might be wrong just because he hasn't given that before, and I've never seen him give that before, so I don't think we'll have to deal with that. Um, Honestly, it'd probably be easier if I just get rid of the prefix part. Yeah, let me just do that. So that's going to be like that, and then from there we can just get rid of the B's. B, B. Okay. And then I'm going to get rid of this part. Oh, just because we have never done that before, so I don't think he would give that to us. And then get rid of the B. Okay. And then expression 1, again, that contains a division symbol, but it's right associative, right? So I'm going to go over here, boom, boom, right associative. So the next expression 0. And the next production is going to be called on the right side. So this is going to be class 1. It's going to be called on the right side. So expression 1, right? And then the next expression, since it's binary, we're going to be putting it. So it's going to be expression 0 right there. And this would work. So again, ignoring these portions here. Oh, ignoring these portions here, right? This would be a valid answer, right? Because anytime we had a right associative, we ensured that the current production is on the right side of the class. Anytime we had left associative, we ensure that the current production is on the left side of the class. And then always expression 0 is just going to be constant, variable, parentheses, expression 3 parentheses. And that would be it for questions that refer to like that want you to make a BNF given some precedence class of some coding language. That would be just the general pattern. Oh, and then always you're gonna have like that such that where the next production is next, right? And then remember just the highest precedence class is always going to be class 1, and the lowest precedence class is always going to be class 3. And then you also have to note that expression 3 is the starting non-terminal. Okay, because we didn't put it at the top, so you have to make sure to note that it's the starting non-terminal. Okay. So that's it for this. That's pretty much it for syntax. Is there any questions about the pattern that you have to know? Any questions about what I just did here? We all good? This was on exam 1, exam 2, so I think you should already know this. Good. Okay. And then again, he can give other questions that involve syntax about like EBNF, BNF. That's possible. Or EBNF, BNF can show up from TinyJ assignment 2 questions. So, be prepared for that. Um, but yeah, that's it for syntax. So we're going to take a quick break. After the break, we will go over some Lisp questions because I know we